Hello friends, I Professor Darshan Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head Control System Engineering. So friends, as far as our today's session is concerned, so we will try to learn this block diagram reduction technique with one basic example basically, right? So as we know, block diagram is nothing but what? It is a pictorial representation of that control system in which each and every element of that control system is to be defined with the help of finite number of blocks along with finite number of summing points and finite number of takeoff points. So ultimately our objective is to determine the overall transfer function of this given control system. So in order to define in order to tabulate the overall transfer function of this given control system, finite reduction rules we are having with us. So as far as this block diagram reduction technique is concerned, so there are 8 basic rules which are used to determine the transfer function of that system. So each time we need to recall these 8 reduction rules to determine the transfer function of that system. So before going for this reduction rules, let us quickly go through the given control system. First of all, we need to map this entire control system from sake of observation. We are having how many number of feedback elements, we are having how many number of summing points, we are having how many number of takeoff points that we need to observe. So as you can see here in this given block diagram, identically there are 3 summing points, right? So this is the symbol of that summing point number 1, this is summing point number 2 and summing point number 3. And as we are having 2 feedback elements with us, H1 as well as H2, so definitely we can say that this will be the takeoff point number 1, T1, and this is nothing but what? Takeoff point number 2, this is nothing but what? The overall output of that system. So we need to determine the transfer function, that is nothing but what? The ratio of output to the input is in terms of S domain, right? So in that first step, what we need to do? Each time while solving this type of example, we need to recall which rule is applicable in that first step, right? So we don't have any blocks, those are connected in series form, or we don't have any blocks, those are connected in shunt form, or directly it is not possible for we people to eliminate these 2 feedback elements H1, H2. Again directly we cannot use the reduction rule number 4 associative law, which says that when n number of summing points are connected in series form, so according to our own convenience we can change its order, right? The remaining 4 rules are nothing but what? The remaining 4 rules belongs to the summing point and takeoff point. How to shift this summing as well as takeoff point before and after this block, right? So in that first step, what we need to do in that first step, we need to shift this summing point number 3 before this block, whose gain is nothing but what? G suffix 1. Because our aim is to what? Our aim is to, we need to eliminate this innermost feedback associated with this H1, right? But currently it is not possible for we people to eliminate this feedback. So in order to eliminate this innermost feedback, what we need to do? We need to shift this summing point before this block G1, right? So whenever we are shifting this summing point before this block, so at that time we need to recall the reduction rule number 5 or reduction rule number 7, key in which how we are shifting this summing point before this block. So the basic logic for that is nothing but what? If suppose such type of scenario we are having, this is block and this is nothing but what? The given summing point, this is the potential of this summing point, this is R, this is G, and this is nothing but what? For sake of our convenience, if suppose this is capital X and this is nothing but what? C, right? So what we need to do? We need to shift this summing point before this block. So before shifting this summing point before this block, here C equals to what? The output of this forward path is nothing but what? R into G. If suppose we are having the addition sign, so C equals to RG plus X. So the statement for that output response of that system is nothing but what? Rg plus X. So whenever we are shifting the summing point before this block, so we should retain the same statement. So for that purpose, see, when this summing point is being shifted before this block G, remaining thing as it is, this is R. So we need to add one more block whose gain is exactly equals to the reciprocal of that original one. So it will become what? See, this is the input, this whole quantity is inputted to this summing point as a result of addition. So it will become what? Its gain is nothing but 1 over g, its input is nothing but r. So the output of this entire path is nothing but what? X over g. And here we are adding these two terms, r plus x over g into g equals to c. So it will become what here? Rg plus x. So it is mandatory for we people to add one more block whose gain is exactly equals to the reciprocal of that original one. So according to that, in that first step, here I will write, we need to shift the summing point before this block whose gain is nothing but what? G1. So as a result of doing this, here I will write the summing point number 1, summing point number 2, it will remain as it is, and this summing point is being shifted before this block G1, right? G suffix 1. As a result of this, see here, we need to add one more block. Wait a minute. Okay, so according to this phenomena, when that summing point is being shifted before this block, so one more block is being added whose gain is nothing but what? The reciprocal of that original one. So the same thing which we need to follow here. For sake of moment, I will rub this reduction rule. Once we know, then it is clear to we people. Okay. Now this block diagram will modify it here. In that first step, see, this is summing point number 1, right? This is summing point number 2. After this summing point number 3 is being shifted, right? As a result of shifting, here one more block is being added whose gain is nothing but what? 1 over g. And already we are having this one more block we are having with us. Here I will draw. This is nothing but what? G3. And this will be the newly added block whose gain is exactly equals to the reciprocal of this G1. So it will become 1 over G1. Here we used to have the plus sign. Here also. This is how. Then this summing point number 2 associated with this feedback element whose gain is nothing but what? H suffix 1. The summing point is being shifted before this G1. So as it is, this H1 is terminated after this G1. This is nothing but what? The G suffix 2 and belongs to this summing point number 1. This will be the outermost feedback denoted by H2. Where it is being terminated, H2 is being terminated after this G2, and this is nothing but what? C of S. So this is how your system will look like. So again we need to follow the same polarity here. This is negative, negative. This is nothing but what? R. This is nothing but what? C. Right. So this is how your system overall system will look like by adopting the reduction rule number 5 or 7. The count doesn't matter for we people. The reduction rule says that how to shift the summing point before this block G1. So in order to shift the summing point before this block G1, we need to add one more block whose gain is exactly equals to the reciprocal of that G1. So for what purpose we are doing all these things? In order to remove this innermost feedback associated with this H1, right? This H1 is being originated after this G1 and it is being terminated across the lower terminal of this summing point number 2. Now, furtherly, simultaneously within that same step, we need to follow the 2 reduction rules. Out of the 2 reduction rules, first one is nothing but what? Very simple. Here I will perform. As we don't have any further elements which are connected in between these 2 blocks, so obviously these 2 blocks are connected in series form, right? Now see, suppose this is G suffix 1 and this is G suffix 2, this is R and this is nothing but what? C. So when we will come to know that these blocks are connected in series form, so their gains are being multiplied with each other. G1 into G suffix 2. This is R and this is C. Right. So the same rule we need to use. So as a result of multiplication, this gain will become what here? G3 into 1 by G1. So obviously it will become G3 upon G1. Here I will write like this. And within the same step, as you can see, if suppose this is nothing but what? Summing point number 1, this is summing point number 2 and summing point number 3. So here clearly we can say that in between summing point number 2 and summing point number 3, we don't have any further elements which are connected in between these two successive summing points. So we are coming on to this conclusion ki these two summing points are connected in series form. So when they are connected in series form, so at that time definitely we can change its order. We can exchange the position of summing point number 2 and summing point number 3. Once their positions are being exchanged, then after that it is very easier for we people to eliminate this innermost feedback, that is nothing but what? H1. So how that system will look like? Here I will draw step number 2. This is nothing but what? The summing point number 1, right? Then this summing point number 2 is shifted to the position at which the summing point number 3 is to be shown. So here by default, this is nothing but what? Summing point number 2. This is summing point number 1. Now this is summing point number 3. And this is nothing but what? Summing point number 2. So what are the associative elements of this summing point number 2? To its lower terminal along with this negative feedback, we used to have this feedback element fellow whose name is nothing but what, or whose gain is nothing but what? H1. This is nothing but what? The forward path number 1, G suffix 1, and after that we used to have this G suffix 2, and this is nothing but what? The output, right? From where that H1 is being originated after this G1, right? Now as far as the summing point number 3 is concerned, to its upper terminal, we used to have this block whose gain is nothing but what? G3 by G1. So in this fashion we need to show this will be G3 by G1. Where it is being terminated? This G3 by G1 is being terminated towards the upper terminal of this summing point number 3 with this addition sign. Here also we are having this plus sign. Then as far as this S1 is concerned, so to its lower terminal along with this negative sign, we used to have the outermost feedback, that is nothing but what? H2. Where it is being terminated? After this G2, like this, right? So now it is clear. Now we can eliminate this innermost feedback H1. What are the associated elements of that H1? Summing point number 2, this forward path number 1, G1, and this is nothing but what? H1. Now definitely we can eliminate this innermost feedback. At the same time, carefully as you can see here, see these two potentials are being added with each other with the help of this summing point number 3, means definitely we can say that these two blocks are connected in shunt form, right? So they are being added with each other. So within that same step, now we need to perform these two actions, right? Which two actions? Here I will show. Or here I will write, these two potentials are nothing but what? This G3 by G1 plus 1. As far as this lower terminal is concerned, whose potential is exactly equals to 1, so this potential plus this potential, these two signals are being added with respect to this summing point number 3. So as a result of this, it will become what? G3 plus G1 divided by G1. As a result of addition, the gain of that additive block will become what here? This G3 plus G1 upon G suffix 1 as a result of addition. At the same time, when this innermost feedback is being eliminated, so as you can see, we are having the negative sign. So its CLTF for the closed loop transfer function will become what here? G1 divided by 1 plus G suffix 1 into H suffix 1. That will be the another block, right? Because we are having the negative feedback according to the characteristics equation, how we are supposed to eliminate this feedback element, the feedback element is being eliminated with this statement G divided by, if we are having the negative feedback, so opposite sign we need to consider G divided by 1 plus G into H. So which G we are having here? G suffix 1, and which feedback element we are having? H suffix 1, right? Now once this innermost feedback is being eliminated, so this whole quantity is to be written within that single block, right? So in that next step, definitely we can say that this newly added block, whose gain is nothing but what? G suffix 1 divided by 1 plus G suffix 1 into H1 is connected in series form with this G2 fellow, right? So it will get multiplied, their gains are being multiplied. So this is how your system will look like. So now how your control system will look like, here I will draw. See, this is your summing point number 1, right? After this summing point number 1, as a result of addition, this block will become what here? This G3 plus G1 divided by G suffix 1, right? As a result of addition, G3 plus G3 by G1 plus 1, it will become G3 G1 plus, it will become G3 plus G1 upon G1. Then after that, this innermost feedback is being eliminated and it is connected in series with this G2. So as a result of this, it will become G suffix 1 into G suffix 2. Its denominator will be what? This 1 plus G suffix 1 into H1. Like this. And the remaining thing is nothing but what? This outermost feedback associated with this H suffix 2. It is terminated after this block, and this is nothing but what? Your output C of S, and this is nothing but what? Your input R of S, right? Now which sign we are having with us as far as this outermost feedback is concerned? So it is associated with this negative sign, right? Means we are having the negative feedback. So in that last step, what we need to do, this whole control system is replaced in terms of these 4 elements, which consist of one summing point, 2 identical blocks, and one is nothing but what? Feedback element, right? One more time, definitely we can say that we don't have any further elements which are connected in between these 2 successive blocks. So obviously these blocks are connected in series form, so their gains are being multiplied. So as a result of this, it will become what? Here I will write G3 plus G1. I will put this thing in one parenthesis. Remaining thing is nothing but what? G1 into G2. This whole term divided by G1 times of 1 plus G suffix 1 into S suffix 1. Right? Why? Because these 2 blocks are connected in series form, so their gains are being multiplied. So furtherly, we can mathematically simplify this. G1 will get cancelled. So here I will write, as a result of multiplication, the gain will become what here? This G3 plus G1. This G1 will get cancelled. G suffix 1 into G2 divided by 1 plus G suffix 1 into H1, right? So like this whole control system is replaced with one forward path with one feedback path along with the summing point number 1, right? So in that last step, as you can see, this whole quantity can be considered as a G, and this is nothing but what? The feedback element. As we are having the negative feedback, so how to eliminate this negative feedback? By adopting reduction rule number 3. Reduction rule number 3 says that here I will write G divided by 1 plus G into H. This is nothing but what? The CLTF, closed loop transfer function. Whenever we used to have the negative feedback along with this forward path, here capital G itself is this whole term which is written within that rectangular box, right? So our overall transfer function will become what here? G divided by 1 plus G times of H. So here G is nothing but what? This whole term. So it will become G3 plus G1 into G suffix 2 divided by its denominator is nothing but what? 1 plus G suffix 1 into H1. this whole term divided by one more time this gth term we need to write g3 plus g suffix 1 into g2 divided by 1 plus g suffix 1 into h1 multiplied by the gain of that feedback path. Then here the feedback is associated with this h2, right? So obviously as when we are considering these terms as a LCM, so these two terms will get cancelled. So remaining term is nothing but what? G3 plus G suffix 1 into G2 upon this whole term will get multiplied with this one. So it will become 1 plus G suffix 1 into H1 plus this G2 H2 times of G3 plus G1. So this is nothing but what? The transfer function, which we can say that, right? So this is how this block diagram reduction technique is used to determine the overall transfer function of that system. So as far as this block is concerned, here we used to have the input R of S, and this is nothing but what? The output C of S, right? Means that entire complicated control system or this entire control system is replaced with the help of one single block by admiring the basic rules or the basic reduction rules in case of this block diagram reduction technique. So I just hope that you had understand all these things belongs to this block diagram reduction technique in this session. Thank you.